Electronic engineer Gina Chacko works for ST Robotics in Cambridge. In this video clip, she explains how they have designed a visual inspection system for the quality control of special screws used in medical implants. The robot is required to pick up the screws one by one and position them in front of a video camera. As the camera records the images, each screw is rotated to enable it to be compared with a standard reference screw.
The robot will pick the screw and it will place in front of the camera and will take 18 images in a 360-degree angle, and it will store it in the memory, and then it will keep the screw back into the tray and will do the image analysis using the supervisory software.
In the computer, the image of the screw is inverted and made negative.
This is the kind of inverted raw image which we got out from the camera. So we had two main problems with this project. One was the alignment issue, another was the in-phase issue. The alignment problem was like, when the robot is picking the screw, it need not be in a vertical line. So we need to do a kind of rotation for that particular screw. So if you see very clearly, you can see, I can find out the center of mass of the screw. So I have drawn a line through that center of mass. And then I have drawn a horizontal line through the tip of the screw, and then I have created a small triangle this way. So by measuring that angle through the Pythagoras theorem, we can find the angle, and doing the rotation we can make it aligned exactly with the reference screw. So then we can do the comparison of the images.
Having corrected for any vertical misalignment, the screw under test is now rotated until it matches the reference screw as closely as possible. A comparison is made by looking at the differences between the images of test and reference screws. As the test screw is turned so that it moves into phase with the reference, the difference image should take on a flat grey appearance.
This is the kind of out-of-phase image which we got straight away from the camera. Then we need to make it in phase till we get this image. Basically, in the in-phase algorithm, what it's trying to do is comparing two images and finding out what's the maximum match it can be. So it will be like, there will be different kind of ranges will be there. So if the pixel value count range is of less than 30 or less than 20, that means the image, the present image or the present position of the screw is more in phase with the reference screw. So at that point the robot will be stopped and we will take that angle and we will make that as a zero angle for the second screw.
Here is the closest match between the screws. The computer now has to decide whether that match is good enough or whether the test screw should be rejected.
If you see very closely, if you see some dark spots, these are the kinds of defects. So there are basically two kinds of defects it can be. Can be missing part or can be some small extra bits. So if it's a missing part, you can see it as the black ones, and if it's an extra bit, you can see it as the white ones. Basically this kind of inspection system we are aiming to use for the purpose of inspecting medical screws like bone screws, cortex screws. There are different kinds of screws are there which are more critical because they are implanted into the body parts. So we need to find out if there is any defect straight away from the factory. So we'll be using this system for inspecting that kind of screws.